Okay, for our topic for today, we have the reduction to normal form for the equation of line. Now, the general equation of the line is equal to what? General equation of the line is ax plus by plus c is equal to 0. Now, to reduce this general equation into its normal form, now let's say we have here that line is drawing this Cartesian plane, which is, this is our y-axis and this is our x-axis, and from this we have this line which is equal to ax plus by plus c, where it crosses the x and y axis, and let's say the point of intersection here, which is our x-intercept. Let's say this is our a0, that is our x-intercept, and for the y-intercept this is 0 b. And as you can see, this line, let's say this is our origin. From the origin there is a line passing through the origin and intersecting the given line, and this line is what? Perpendicular to the given line, which is ax plus by plus c is equal to 0. Now for this, let's say this point and this point is a segment. Let's say this is a segment rho, which is the distance or the perpendicular distance of this line to the origin, and the length of this side is, since this one is our x-intercept, is equal to a, and the length of this side, this point and this point, is our y-intercept, which is equal to b. Now let's say this side, say this is our angle beta, and as you can see we have a similar triangle that is equal to this triangle and to this large triangle. This is also equal to beta. Okay, and this triangle has, let's say, has a sides of, from this point up to that point, that is our a, and for this triangle, this side, the length is b. Okay, now looking into this triangle, our cosine beta is the adjacent side. The adjacent side of this triangle is rho, and the hypotenuse is our x-intercept a. And for the sine beta is equal to the opposite side of this triangle is rho all over its hypotenuse is our y-intercept. And again, here we can say that the value of a here, the value of a is equal to rho over cosine of beta, and for our y-intercept, that is rho over sine of beta. Again, we know that the equation of line, or for the intercept form of line, we know the intercept form of line is, we have x over a plus y over b is equal to 1. And again, substituting the value of the x-intercept and y-intercept to our intercept form, we can say that this one is equal to x over a again is rho over cosine of beta. Let me fix this one. This one is rho okay plus y over f tara over sine beta, which is equal to 1. And simplifying this one is also equal to x cosine of beta over rho plus y sine of beta over rho is equal to 1. Now if you multiply here rho, this one is also equal to, let's write it here, we have x cosine of beta plus y sine of beta is equal to rho. Okay, we're in this one, which is rho, this one, we're in this one, that is the distance of the perpendicular distance, say perpendicular distance of line to the origin, okay. Now next, again, that is this one, this whole equation. This is the polar distance, or I mean the polar equation of line. Okay, now going back to the general equation, which is equal to ax plus by plus c is equal to 0. Now we have a condition here wherein the value of c is greater than 0. If you transpose c to the right side, we have ax plus by is equal to negative c. Now going back to the polar equation of the line, we can see that our cosine beta is approximately equal to a, sine beta is approximately equal to b, and for the rho, that is approximately equal to c. Then we have here condition wherein, let's say, our cosine beta is proportional to the value of a. Now to change that proportionality symbol, let's try to replace that to 1 to a proportionality constant. Therefore we can say that cosine beta is equal to ka. That is also equal to what? Let's say sine beta is proportional to b, then changing the proportionality symbol to a proportionality constant. This one is equal to kb. And for rho, which is proportional to negative c, you can say that rho is negative kc. Okay, next, we know from our trigonometry that cosine squared beta plus sine squared beta is equal to 1. Now for the cosine squared beta, let's try to replace cosine beta by this equation, or the value of cosine beta. Therefore cosine beta is equal to ka, then this one will be squared plus this one is kb squared, which is equal to 1. Therefore here simplify this one, k squared a squared plus k squared b squared is equal to 1. Then let's try to factor out k squared. What is left is a squared plus b squared is equal to 1. Then we can cross multiply this one. We have 1 over a squared plus b squared. Then getting the value of k, what is the value of the proportionality constant again? K is equal to what? The positive and negative value of 1 over the square root of a squared plus b squared. That is the value of k. Now we have a condition again wherein if c is greater than 0, looking back to the equation, if c is greater than 0 and if we transpose that 1 which is positive to the right side, it will become negative. Therefore we'll be using the value of k here, which is equal to the negative of 1 over square root of a squared plus b squared. Now let's try to simplify, get the normal form of the line. Getting the normal form of the line, we will be using x. This one is cosine b beta k a. Okay, now let's try to change this one, this polar equation. Again, here we have x cosine beta is equal to ka plus y sine beta is kb is equal to rho is equal to what? Negative of kc. Okay, now again we know that the value of k is what? Negative 1 over square root of a squared plus b squared. Therefore here we can do, we have xa over negative square root of a squared plus b squared plus yb over square root of a squared plus b squared is equal to negative c over also square root of a squared plus b. Let's calculate this one. Let's move. We have b squared. Okay, now this equation, this new equation, wait, this one should be negative, or if you simplify this one, we have negative over negative, this one will become positive. This equation will be the normal form of line. We have addition here. Let's say since rho is equal to negative kc, we can say that the distance, to get the distance of this line to the origin, which is rho, that is equal to negative c all over, which is this one is a constant, all over the negative square root of a squared plus b squared. Let's make it positive. That is c over square root of a squared plus b squared. This is the formula for the distance, the perpendicular distance of the line to the origin, which is 0, 0.